Hello guys, so today we are going to solve we are going to print Fibonacci series using recursion. So print Fibonacci series up to n using recursion, right? So I'm going to take n as an input from the user, and then I'm going to print the Fibonacci series for that. So first let's see what a Fibonacci series is, right? So it is simply one, as it starts with 0 and 1, and then we add 0 and 1, so we get again 1, then we add 1 plus 1, so we get 2, then we get 1 plus 2, which is 3, 2 plus 3, which is 5, 3 plus 5, which is 8, 8 plus 5, which is 13, 13 plus 8, which is 21, and then so on. So this is a Fibonacci series. Now first we find the base case. So base case is that, okay, so we are printing it till n, right? So the base case should be if let's say a plus b is greater than or equals to n. So if this happens, we can simply return let's say 0 for only greater than not equals to. So if this happens, then we return 0. So the last number is 0. It doesn't matter. So this should be the base case, that as soon as a and b, which will be two variables inside the Fibonacci series only. So if this reaches our condition that a plus b is greater than n, then we return 0. And the relation we can see, that is relation, so the relation that I can see is we have a equals to 0 first, and then b equals to 1, and then we add a plus b. First we are printing it, so okay, I have to write it here only. So print a comma b. So this is one thing. So this is not inside the relation, so I'm going to take it outside the recursion part, right? So this would be done outside the recursion part. After that, in the recursion part, what we have is we add a plus b, and we print, so I can write directly, so print a plus b, right? This is we are doing or I can say, yeah, we're returning 0 whenever I'm printing. So yeah, so I'm printing this if a plus b is less than n, right? So if a plus b is less than n, this is what we do. Else we just simply return 0, and that is printed. So let me generalize this relation. So actually this is one of the generalized relation only. Generalized relation. So this is one of the generalized relation. The relation which we can take is that we can take an example. So if we are taking an example, we already have this example. Let's say if we have n equals to, let's say 14. So if n equals to 14, we get this series. This is our output, right? So 0 and 1 is printing. There is no recursion used there. After that we have recursion, and which is used in this generalized relation. So let's code this. So I have created this recursion Fibonacci series. Now let me put a main method here, public static void main. Yes, so I have a main method string. Now let me import the scanner so that I can take the user input. So scanner sc is equals to new scanner system.n. So I have a scanner. Now let's first ask the user to enter n. So user will simply enter its in, then we can take it in this variable next int. Now we can create the recursive function. So as usual, it should be static. It should be, so it should return a integer. So int, so it's returning an integer. So static int, and then we can say Fibonacci. Right, so it will take int a comma int b comma int n every time. Yes, so this is what it will take. So we'll check if a plus b is greater than n. So if anytime this becomes greater than n, we simply return 0. Else what we do is we will print first. So print a plus b and followed by a comma. So we are printing this and then we are checking again. So what happens is a becomes b and b becomes a plus b. So we can simply write, okay, let me show this to you also. So every time in the next iteration, so this is first, let's say this is a, let me write it here. So in the first round, a equals 0 and b equals 1, and then we simply add both of them for c equals 1. Now in the second iteration, what happens is a becomes 1, so a becomes b, we can say a becomes 1, and then b becomes c, so b becomes 1 again, and then we get c equals to 2. Now in the third iteration, if you see this third iteration, this one, for this number 3, so what happens is a was first 0, then it changed its position with b, a become b and b becomes c. This is what happens, that a and b is this, so a plus b is c. Then we take these two, so a becomes 1 and b becomes 2, and then we get c as this, and then we take these two, so a becomes this and b becomes this. So this is what actually happens in the memory also. So that's what we are going to do. So we have this. Now I'm going to call Fibonacci here. So a becomes b, so simply I can write b becomes c, so we have a plus b, and then we have n, which is as usual. So this should be a return statement, so return Fibonacci. So I think this should work. Let's run this. Okay, so I have to enter n. So let's say again I put 14. Okay, it doesn't print. Okay, I think I forgot to save it. Just print a plus b. Okay, I'm not calling it. So system.out. So I'm factorial for, let's say, n, and then we get here. Oh, I've written factorial. Sorry. Fibonacci for n is Fibonacci of 0, 1, n. So let's see if this works. Run file. So we are here. Let's enter 14. So we get 0, 1, 2, 3, 5, 8, 13, and then Fibonacci for 14, 0. So I think we do not need to print this. We just simply can print this. Yes. So if we want to print that, we can print it here. So Fibonacci till n, we can see is this. So if again I run this, let's say this time it's 50. So Fibonacci till 50 is 0, 2, 3, 5, 8, 13, 21, and 34. It's not printing 0 and 1 because we have to print it before. So let's say if I'm printing it, I can simply put here, so 0, 1, and then we have the other series. So if I run this again, and let's say this time I put 100, so we get Okay, so it's what's happening here is it's printing after, so I have to print it here only. So I'm going to remove this and I'm going to put slash in 0 comma 1, and then it's printing after because first this Fibonacci is called, and so that's how we print everything, and then this is printing. So that's not the code fault, it's my fault. So this time let's put 100 again. Yeah, so we get 0 1 to 1 2 3 5 8 13 21 34 55 89. So as you can see, it's working fine. And yeah, so this is how we can print Fibonacci series using recursion. Thank you.